Good evening, everyone. In today's session, we will have the second part of wave optics. We have seen the fundamental part, fundamental ideas of wave optics, different theories regarding light, nature of light, and then reflection and refraction based on wave theory, Huygens principle of secondary wavelets, and wavefront and all those stuff. Okay. So today's discussion, we will have interference, and to start with, we will have principle of superposition. You heard about principle of superposition before, right? In electrostatics, you have seen principle of superposition. Superposition means just summing up, okay, adding up. All right, so I'll tell you the basic idea here. Just imagine I have a wave here. All right, I have a wave here. This is one wave. The wave has a crest and a trough. This is called a crest. This is trough. Again crest, again trough. It goes like this. And I got another wave here. See the wave that is a little taller than the first one. All right. And both of them vary together, which means they are in phase. Okay, we have only discussion for waves in phase. These waves are in phase. Look at that. They are starting together and they are crossing x-axis together, again x-axis together, right? So they are moving simultaneously. Only thing is that, they are having different amplitudes. See this? This one has an amplitude of, I would say it is A. Amplitude means the maximum height of the wave. And second one has an amplitude of B. All right. Okay, so first one has an amplitude of A, second one has an amplitude of B. And I have two waves here. First wave is Y1 is equal to A sine omega t. Y1 is equal to A sine omega t. Okay. And I have a second wave here, which is Y2 is equal to B sine omega t plus phi. I've taken two waves here and they differ in phase. As a general case, I should take what? This is general case, right? Here I've taken phi is equal to 0. They are starting together, right? If phi is written, that means second wave is starting a little later. All right. Anyway, let's come back to that later. I have two waves here, Y1 and Y2. You learned the mathematical expression for wave in first year classes, traveling wave. Sine function, A sine omega t. A is the amplitude. Omega is angular frequency, A sine omega t, and Y2 is equal to B sine omega t plus phi. What is principle of superposition then? According to principle of superposition, if they superimpose, if two waves superimpose means join together. If they join together, the resultant displacement is given by Y vector is equal to Y1 vector plus Y2 vector. Okay, I'll tell you about it. Look at this. For example, forget about the displacement. At some other location, let the height be Y1. Here the height is Y1. The displacement is Y1. At the same location, the height here is Y2. All right. And let them fall on each other. Let them superimpose. Let them join together. And we will have what? We will have a wave whose amplitude is the sum of these two. At this point, the height here should be what? Y1 plus Y2. That is what it says. Principle of superposition says Y1 plus Y2. See this? The first wave has a displacement of Y1 at this location. Look at that, Y1. Y1 is the displacement for the particle. At the same location, the displacement here is Y2. All right. So one is Y1, second is Y2. So what is the resultant displacement here? It is Y1 plus Y2. And that is valid for any point. Look at this. Here the displacement is what? 0, because it is on the x-axis itself. And at the same location, displacement is 0. 0 plus 0, you expect 0. Yes, exactly. That is 0 here. All right. So this is what principle of superposition says. And why did I particularly write Y1 plus Y2 as vector quantities? Because, there can be a different case where the waves might superimpose out of phase. Look at this. Look at this. Out of phase. Just let this be Y1. And at the same position, the height be Y2. And how about the resultant wave then? That has to be Y1 minus Y2. These are actually superimposing out of phase. Y1 minus Y2. So take the difference between them. So that will be a wave like this. This height will be what? Y1 minus Y2. If Y1 and Y2 are equal, we have a wave with 0 amplitude. Y1 minus Y2 will be 0. So this is the basic fundamental idea of superposition principle. I'll repeat one more time. We have principle of superposition. Superposition. This is what we learn in the concept of interference. Principle of superposition of waves. What is meant by superposing? Superimpose or superpose means join together. All right, two waves are going to join together. All right, so one wave is coming from here, another wave is coming from here. They are going to fall on each other. All right, and they are going to superimpose and give you something like a pattern. We'll come to that later. That's called interference pattern. For the moment, let us analyze this mathematically. So what do we have here? I told you we have a wave here. This is one wave, which is having a displacement of y1. Displacement means what? At this location, I just draw a line up, vertically up. So that height will be y1. At the same position, for this wave, the height is y2. All right. And when they are allowed to join together, when they are allowed to superimpose on each other, the resultant wave will be what? Resultant wave will be having an amplitude or having a displacement which is equal to the sum of these two. At the same location it is, here it is y1, here it is y2, this has to be y1 plus y2. That is valid for, like I said, any instant. Even this instant, here it is 0. Look at that, it coincides with x-axis. Here it is 0. 0 plus 0 is 0. Correct. And this can even be out of phase superposition. Out of phase means what? One wave is going up here, right? Look at this. The wave is going up while this wave is going down initially. So they are said to be out of phase. Out of phase. So this wave has a displacement of y1 here. And this wave has a displacement of y2. Since they are out of phase, you must take the difference, y1 minus y2. Here it is y1 plus y2. Here it is y1 minus y2. So take the difference between them. You will have a wave of lesser amplitude, right? This height will be what? This height at the same location, this height will be what? This is y1, this is y2. So then that must be what? This must be y1 minus y2. And if they have perfectly same amplitude, for example, this is y, this is y, what will happen? Y minus y will be 0. You will have perfect contrast or perfect destruction. Perfect destruction. So this is principle of superposition. Vector y is equal to vector y1 plus vector y2. They have taken two waves here. Y1 is equal to a sine omega t. What is A? Amplitude of the first wave. What is B? Amplitude of second wave. So they are of different amplitudes, as you can see. Amplitude means maximum height. What is amplitude again? Maximum height is called amplitude. All right. And what is omega t? The phase angle. What is a phase angle here? Omega t plus phi. Why should I take plus phi? Here they are in phase, no? They are starting together. But I can give you another case. Look at this. This wave is starting here and this wave is starting a little later. Look at that. With a phase difference of phi. Understood? So I must take the general case and later on I can put phi value as 0. Understood? So what I've drawn is for phi is equal to 0. They are in phase. But this is general case with a phase difference of phi. Understood till this point? Let's have a quick revision of what we have learned so far. We started with the concept of interference. Before getting into interference, we need to know what principle of superposition means. Superposition or superimposing means joining together. So you're going to see what happens when two waves join together. Two waves are superimposing on each other. All right. And this is given by the principle of superposition. According to principle of superposition, if two waves superimpose on each other, the resultant displacement is given by y vector is equal to y1 vector plus y2 vector. What does it actually mean? I got two waves here. Look at that. These are two waves. First one has a displacement of y1. Second one has a displacement of y2 at that location, same location. No? And if they fall on each other, if they join together, you're going to get a wave which will have a height of y1 plus y2 at the same location. Look at that. Here it is y1, here it is y2, here it is y1 plus y2 at the same location. And like I said, that is possible for any point. At this location it is 0, at this location it is 0, 0 plus 0, it is 0. All right, so at any point, this wave will be the sum of these two waves. All right. And what if they are superimposing out of phase? See this? This wave is going up while this wave is coming down. They are out of phase. 180-degree phase difference, right? They are in phase here. No, there the phase difference is 0. Phi is equal to 0. in phase. I've taken a special case. And this time I've taken phi is equal to 180 pi. So the phase difference is 180 degree. In that case, there will be destruction. That is called construction, constructive superposition. This is called destructive superposition. Construction, no? All right. And this is destruction. Here, we're going to destroy energy, not destroying energy. This is actually destruction. Amplitude is destroyed. Height is y1 here. At the same height, this position, y2 here. So the resultant has to be y1 minus y2. The difference of them, why difference? Because one is in the upward direction, the other one is in the downward direction. So they are out of phase. You need to take the difference between them, y1 minus y2. And I said, if they are perfectly equal, look at this. This wave has a height of y. This wave is identical, but in opposite direction, y and y. So that makes it what? Y minus y, 0. You will have perfect destruction then. All right, 0 amplitude. Anyway, I've taken two waves here. That is what we have seen so far. And we have taken two waves here. What are the waves? I've taken two equations which I learned in class 11. We have learned the equations for a traveling wave in class 11. Traveling wave is given by, traveling wave is a wave that can travel. And it is given by A sin omega t. So first wave has a displacement given by A sin omega t. Second wave has a displacement given by B sin omega t plus phi. And when they join together, what do we get? Y is equal to y1 plus y2. So you can add them up. What is this? A sin omega t plus B sin omega t plus phi. And if you treat this mathematically, in the end, you're going to get something. Look at this. I'm going to tell you the resultant amplitude. What is amplitude of this guy? It is A. What is amplitude of second one? It is B. So when they superimpose, what you expect is A plus B as the resultant amplitude. But instead, what you see is the resultant amplitude is something else. A square plus B square plus 2AB cos phi. You'll learn this in class 11 in parallelogram law of vector addition. So you have to apply the principle of parallelogram law of vector addition. This is like phasor. Phasor is a kind of vector, okay? Vector drawn using phase angles. So this is the point. The point is very simple. First wave has an amplitude of A. Second wave has an amplitude of B. And when they join, the resultant amplitude is not A plus B. It is what? Root of A square plus B square plus 2AB cos phi. This is root of P square plus Q square plus 2PQ cos theta. You learned this in class 11 as parallelogram law of vector addition. So this is resultant amplitude. But my intention is to get resultant intensity. When two waves join together, what's the intensity going to be? Intensity equation, do you remember from class 11? If you don't remember, I'll tell you. Intensity is given by K into amplitude square. K into amplitude square. That is how you write intensity. Intensity is directly proportional to amplitude square. Intensity is equal to a constant into amplitude square. Okay. So Ka square. So let us put this K into, what is A square? The square of this, right? A square. So I can put this in a bracket, A square plus B square plus 2AB cos phi. One last step, I'm going to expand this. K into A square, Ka square plus K into B square, KB square plus K into 2AB, 2KAB cos phi. I repeat this one more time. Look at this. What have I done now? I've taken two independent waves. What are the waves called? First wave has a name. Y1 is equal to A sin omega t. A is the amplitude of the wave. Amplitude means what? Amplitude means the height of the wave. Height of the wave is called amplitude. Second wave has an amplitude B, and they differ in phase by phi. So they have a phase difference of phi. So it looks like this second wave is starting somewhere here with a different amplitude. Okay, this is B, this is A. They have a phase difference of phi. Okay, they are going to superimpose now. Tell me what now? The resultant displacement is given by superposition principle, which is y vector is equal to y1 vector plus y2 vector. That is A sin omega t plus B sin omega t plus phi. All right. And this is my resultant displacement. And if with rigorous treatment, which is not required at the moment, you will get something like this. All right. This derivation is Not there in syllabus. It was asked only once in last 15 years. But anyway, I'll do it in the end. All right, as a numerical. So don't worry about it. Anyway, this is what you're going to get. A is equal to, that involves a little bit of trigonometry. A is equal to a square plus b square plus 2ab cos phi under root. This is the equation for resultant amplitude. You expected what? You expected a plus b, right? First one had an amplitude of a, second one had an amplitude of b. So when they join together, our expectation is like a plus b. But instead, what you see is root of a square plus b square plus 2ab cos phi. And I can find the intensity now. How do you find intensity? Class 11 waves, intensity is directly proportional to amplitude square. So intensity is equal to a constant into amplitude square, Ka square. So K into A square, that is K into A square. The square root gets gone, right? So A square plus B square plus 2AB cos phi. And if I expand this into the bracket, what am I going to get? K into A square, Ka square. So this is resultant intensity, okay? K into A square, Ka square. K into B square, Kb square. Plus 2 into K into AB cos phi, 2Kab cos phi. I'll tell you one last thing now. See this. See this. I wrote intensity as Ka square, okay? So I can write the intensity of first wave as Ka square. First wave, intensity of wave A, first wave, K into its amplitude square. Intensity of B is what? Second wave, K into B square. All right. So intensity of A into intensity of B is what? I'm just multiplying. Ka square into Kb square. All right. And I take root of IAIB. What do I get if I take square root of this? For 2Ks, I'll get 1K. Square root of A square is A. Square root of B square is B. Why did I do all those stuff? Because Kab I have here, no? Kab. So I can write what now? Ka square is what? It is Ia, intensity of A, plus Kb square is what? It is Ib, plus 2 into, what is Kab? Kab is called root of Ia, Ib into cos phi. This is the resultant intensities equation. So contrary to our expectations, we were expecting what? Intensity. When Ia intensity and Ib intensity join together, you expect Ia plus Ib. But instead, we see a third term, which is going to be called interference factor. Interference factor, which causes a beautiful phenomenon called interference in physics. Okay, interference. Okay, interference of light. See, same can be seen in interference of sound also, sound waves also. Okay. Anyway, I'll repeat these mathematical steps one more time. Look at this. I have intensity. Intensity is written how? K into amplitude square. So K into amplitude square. Square of this. Square of this means A square, B square, 2AB cos phi. If I expand, I get what? K into A square, Ka square. K into B square, Kb square. Then K into 2AB cos phi, 2Kab cos phi, 2Kab cos phi. All right. Then I've taken intensity as K into capital A square. That is for the resultant wave. This is for the resultant wave. Okay. What are we looking at? We are looking at two waves joined together and we are trying to find the resultant intensity. That's it. As simple as that. So resultant intensity is Ka square. Okay. So for one wave, I can write what? Ia. For the first wave, Ia is equal to K into its amplitude square, A square. Second wave, Ib, second wave, K into its amplitude square, that is Kb square. I just multiply them, Ia into Ib, that is Ka square into Kb square on the right side. And if I take square root of it, square root of Ia into Ib, what is it? Two K's are there, so I'll take one K instead. A square square root is A, B square square root is B. So in place of Kab, I could put what? Root over IAIB. So I got a Kab here, so I'm putting root of IAIB. So what I have is I is equal to Ia plus Ib plus 2 root IAIB cos phi. This is the equation for final equation for finding intensity, resultant intensity of two waves joined together. Okay. So what is the context again? We have two waves. Which are the waves? A sin omega t and B sin omega t plus phi. What do you think about it? What do you think about them? They are having different amplitudes and they have a phase difference also. When they join together, the resultant intensity is given by IA plus IB. That means intensity of first wave plus intensity of second wave plus 2 into root of intensity of first wave into intensity of second wave into cos of phase difference. Cos of phase difference. This equation is very important, based on which we will have many numericals. Did you understand all these points? So whatever we learned today, I need you to memorize two equations. First equation is this. The resultant amplitude is given by a square plus b square plus 2ab cos phi. That is one equation, okay? Resultant amplitude, when two waves of two different amplitudes are joined together, that is what you get. The resultant amplitude is this, and resultant intensity is given by what? IA plus IB plus 2 root IA IB into cos phi. So you need to memorize these equations: IA plus IB plus 2 root IA IB cos phi. And the last term, which is causing the phenomenon of interference, is called interference factor. Interference factor. So the last term is called interference factor. Interference factor. Okay. All right. So let us see the conditions here. I'll tell you. I'm going to find the conditions for maximum intensity and minimum intensity. Why are they needed? I'll tell you. I'll answer that question later on. Okay. So what we're going to do is we will find the conditions for maximum and minimum. Maximum and minimum. So let us see this maximum first. Okay, I'm going to find the condition for maximum. When do we have maximum here? If I need this equation to be maximum, I need what? I need cos phi to be maximum. Cos phi to be maximum. Cos phi's maximum value is what? 1. Correct? You know, if you want, see, what is my intention? I need to get maximum intensity. If I need to get maximum intensity here, if I need I to be maximum, I told you this cos phi has to be maximum. These are not variables. Only this you have to be concerned about the last variable. I mean cos phi. Cos phi has to be 1. Cos phi's maximum value is 1. And cos what is 1? Phi value is what? Phi value can be 0. Cos 0 is 1. Or cos 2 pi is 1. 2 pi, cos 2 pi, cos 360 is 1. Cos 4 pi is 1. Cos 6 pi is 1, etc., etc. In general, I can write phi is equal to n into 2 pi. That is a condition for maximum. All right, where n can take which all values? 0, 1, 2, etc., etc. I repeat that one more time. Look at this. What is the condition here? I told you this is the equation for resultant amplitude. Resultant amplitude should be in square root. Thanks for that. Root of a square plus, I made a mistake, a square plus b square plus 2ab cos phi under root. All right. And the intensity, resultant intensity is given by IA plus IB plus 2 root IA IB cos phi. Okay. So we're going to find the conditions for maximum intensity and minimum intensity. I'll tell you the physical significance of this later on. Why we need maximum, why we need minimum. Okay, you're going to see a pattern in which there are bright band and dark bands are present. Okay. For the moment, let's forget about those things. I'm going to find the condition for maximum. Maximum is what? This equation will return you maximum when cos phi is 1. Cos phi's maximum value is 1. Cos what is 1? Cos 0 is 1. Cos 2 pi is 1. Cos 4 pi is 1. Cos 6 pi is 1. Cos 8 pi. Even numbers, or even numbers. Even multiples of pi. So in general, I can write n is n into 2 pi. Phi is equal to n into 2 pi. You put n is equal to 0. 0 into 2 pi, 0. N is equal to 1. 1 into 2 pi, 2 pi. N is equal to 2. 2 into 2 pi, 4 pi. N is equal to 3. 3 into 2 pi, 6 pi. So I got the condition for maximum now. This is the condition for maximum. What is this? This is phase difference. Okay. Phase difference. Now let's come back a little backwards. I'll tell you, look at this. You know, I have a wave here. All right. And the second wave starts here. All right. So what is the path difference between them? Can you tell me the path difference between them? The path difference between them is actually the wavelength, lambda. Because this wave is starting over here and the second wave starts over here. So what is the distance between them? Path difference is lambda, right? one half wave, that will make one full wave. Length of the wave is called wavelength, right? So path difference is lambda. What is phase difference? Look at this. This is 0, pi by 2, pi, 3 pi by 2, 2 pi. So this is 2 pi. One full cycle means it is 2 pi, right? One full cycle means it is 2 pi, right? So a phase difference of 2 pi corresponds to path difference of lambda. I repeat one more time. Look at this. I have taken two waves. This wave is starting over here at 0, and second wave is starting a little later. Where? At this point. So what is the distance between them? The distance between the starting points is lambda, one full wavelength. That is called path difference. So path difference of lambda corresponds to what? They have a path difference of lambda. So what is the phase difference? This location is 0. This is pi by 2. This is pi. This is 3 pi by 2. This is 2 pi. You learned that in trigonometry. So whenever there is a phase difference of 2 pi, corresponding path difference is how much? Lambda. So what if the phase difference is 1 radian? Path difference will be lambda by 2 pi. Look at that. This 2 pi is taken to denominator. So for 1 radian, it is lambda by 2 pi. So what if it is 5 radians? It is lambda by 2 pi into 5. In school, they might ask you to learn this equation by heart. Even in textbook, they have written this equation as such. But this is how you get the equation. So you need to have an idea. Otherwise, numericals will be difficult for you. I can repeat the points one more time. We have taken two waves. All right. This is the starting point of the first wave, and that is where the second wave starts. Look at that. What is the path difference between them? The path difference. Path. This is half wave, another half wave, that will be one full wave. So full wave's length is called wavelength. So path difference is lambda. What is the phase difference? 0, pi by 2, pi, 3 pi by 2, 2 pi. So a path difference of lambda corresponds to phase difference of 2 pi. So what is phase difference of 1 then? This 2 pi will be taken to denominator, lambda by 2 pi. So in that case, for 2 radians it is lambda by 2 pi into 2. 3 radians it is lambda by 2 pi into 3. 10 radians it is lambda by 2 pi into 10. 5 radians it is lambda by 2 pi into 5. Understood? So phase difference, for a phase difference of 5, the path difference how much? Lambda by 2 pi into 5. Why did I do that? I can find the path difference, condition for path difference now. Path difference is usually called delta. How do you find path difference? Lambda by 2 pi into 5. Lambda by 2 pi into 5. That is lambda by 2 pi into 5. I have written here n into 2 pi. 2 pi get cut. You get n lambda. Delta is equal to n lambda is the condition for maximum. Path difference equal to n lambda, because phase difference is difficult to visualize. Understood? Calculations are also difficult. So you need to convert this. Actually, this condition is okay, phase difference, no? But it is in terms of phase difference. You better have a condition in terms of path difference. So you were just converting phase difference to path difference. That's it. And I'll tell you what it actually means. I repeat this one more time, then I'll ask you. So we are trying to find out the condition for maximum. When two waves superimpose, the maximum, the condition for maximum is what? I told you cos phi. This function has to be 1. Maximum value for cos phi is 1. So cos phi is 1. Cos what is 1? Cos 0 is 1. Cos 2 pi is 1. Cos 4 pi is 1. Cos 6 pi. Even multiples. These are all even multiples. Okay. Even multiples of pi should be 1. So I can generalize as phi is equal to n into 2 pi. N is equal to 0, 1, 2, 3, etc. 0, 0 into 2 pi, 0. 1 into 2 pi, 2 pi. 2 into 2 pi, 4 pi. 3 into 2 pi, 6 pi. So this is in terms of phase difference, but I'm more concerned about path difference. How do you convert phase difference to path difference? You just have to learn this final equation by heart, but I just gave you the idea. All right. I have one wave here. I have a second wave starting over here. Look at the path difference between them. Path difference is lambda, whereas the phase difference is 2 pi. So phase difference 2 pi, path difference lambda. So phase difference 1, path difference is lambda by 2 pi. And this is for 1. If it is for 5, multiply by 5, as simple as that. So I can get the condition for maximum in terms of path difference. Path difference is delta equal to what? I told you. Path difference written as delta. Delta is lambda by 2 pi into 5. Lambda by 2 pi into 5. Pi is what? N into 2 pi. So 2 pi get cut. You get n lambda, where n can take which all values? 0, 1, 2, 3, etc. etc. Understood this? Now this is how you get the condition for maximum. Maximum condition is cos phi. I need this equation to be maximum. For that, cos phi has to be maximum. Cos phi's maximum value is 1. And what value of phi satisfies this? Phi is equal to 0, phi is equal to 2 pi, phi is equal to 4 pi, etc., etc., etc. Or if you generalize, you get phi is equal to n into 2 pi. And n is 0, 1, 2, 3, etc. So you can get a condition. This is condition in terms of phase difference, but it is better to have a condition in terms of path difference. How do you convert phase difference to path difference? I told you this is the equation with the help of which you can convert phase difference to path difference. So whenever you have a phase difference of phi, the corresponding path difference is lambda by 2 pi into phi. So I'm finding path difference now. Delta is equal to lambda by 2 pi into phi. So 2 pi and 2 pi are cut. It is n into lambda. Delta is equal to n lambda, where n is equal to 0, 1, 2, 3, etc. is the condition for maximum. Maximum means brightness or constructive interference. I'll tell you. Before moving to condition for minimum, I'll just tell you the experiment. Then you'll have a better idea. Okay. There is an experiment called Young's double slit experiment. Young's double slit experiment. Okay. Young, it was done by Young. Okay, Thomas Young. Young's double slit experiment. You have a source of light here, bulb, and you have a screen here at a distance. And on the screen, you have uniform illumination of light. Okay, so if you have a screen in front of a source of light, light is uniformly distributed here, right? But if you introduce a pair of slits in front of this, what is a slit? Slit is like a cut made using a blade. Another cut here. There are two cuts here, okay? All of a sudden, you see a pattern on the screen. So you just put two slits over here. These are called slits. And on the screen, what you see is a pattern of alternate bright and dark bands. Alternate bright and dark bands like this. Bright, dark, bright, dark, bright, dark, bright, dark, like this. This is central band, which is called the zeroth bright band. Zeroth bright band. This is zeroth bright band. This is first dark, then first bright, then second dark, and then second bright, then third dark, second bright. Similar way downwards, if you go, this is first bright. This is first dark. Okay, this is first dark, first bright, and then second dark, then second bright, third dark, third bright likewise. Okay, till this point. Okay, third dark. Right. You can go on till nth band. Okay. So this is what you see, and this pattern is called interference pattern. What has happened here? At some positions, there has been destructive interference, and at some other locations, there has been constructive interference. So I repeat one more time. What did we have in the beginning? We had a source of light. That is, and Young used sodium vapor lamp. You know what sodium vapor lamp is? You take a common lamp and then add some common salt to it, to the flame. That makes it a sodium vapor lamp. That is what Young did. Okay, Young, while doing this very famous experiment, put some common salt into the flame, sodium chloride into the flame. That made it a sodium vapor lamp. But in your school laboratory, you have sodium vapor lamp. You've seen the street light, right? Yellow street light, yellow colored street light. Yellow colored street light, that is sodium vapor lamp. Okay, I'll tell you why we choose sodium vapor lamp. Even sodium vapor has two sodium wavelengths, Na1 and Na2. Sodium vapor 1 has 5890 angstrom wavelength. Second one 5896 angstrom. Actually, what we need is perfectly monochromatic light for this experiment. Monochromatic. But in your school laboratory, they can't afford to have a perfectly monochromatic source of light. So they are using the sodium vapor lamp. That's actually bichromatic. 5890 angstrom and 5896 angstrom. And for calculations, we take the average, 5893 angstrom. But in high-end laboratories, like scientists do, they use red laser, which is perfectly monochromatic. Red colored laser. Red laser. Red laser is perfectly monochromatic. Monochromatic means what? Mono means single, one. Chromo means color, one color light, single colored light. That's an essential condition for Young's double slit experiment. I mean, interference to happen. All right. I'll come to the conditions later on. But anyway, let's just have an overview of the experiment. All right. So this is what we see. We have a source of light here. And when you have a screen kept alone, the screen has uniform illumination, uniform intensity everywhere. And if you bring in a pair of slits, these are two slits. Slit means what? Slit. SLIT. Slit means they are two cuts made using a blade. All right. And then on the screen, you have a pattern. The pattern is what? The pattern consists of alternate bright and dark bands. Bright and dark bands. Bright and dark bands. These are also called fringes. And the experiment is called Young's double slit experiment. So there is bright band. Central band is called zeroth bright band. Zeroth bright, first dark, first bright, second dark, second bright, third dark, third bright, fourth dark, fourth bright, fifth dark, fifth bright, goes on like this. Downwards also, same thing gets repeated. First dark, first bright, second dark, second bright, third dark, third bright, fourth dark, fourth bright, etc. etc. So this is what the experiment shows. All right. So we have alternate bright and dark fringes, and the experiment is called Young's double slit experiment. And the maximum I was talking about is this thing, this thing, this one, this one. These are all maxima. All right. And minimum is what? Minimum is dark band. Do you get the concept here? So we have seen the condition for maximum. We will move to condition for minimum later. But anyway, I've told you that the condition for maximum is what? Condition for maximum, we just found the condition for maximum. What was the condition? Path difference is equal to n lambda. Path difference equal to n lambda. And we are going to visualize what happens or in which context it is to be used. This is what we do. We have a source of light. All right. We have a source of light. I'll do that again. We have a source of light. This is a source of light. Okay. And in front of the source of light, you're keeping a screen. Right here, you're keeping a screen. This is a screen like whiteboard or something. So you have light everywhere, uniform light. Okay. Light is distributed evenly everywhere. And then you are bringing two slits, a screen with two cuts. These are called slits, SLIT, slits, okay, in front of the source of light. All of a sudden, the screen changes into something else. Look at that. Look at that. This is called the zeroth bright. The central maximum, central band is called, these are called bands or fringes. Bands or fringes. Central band is called zeroth band, zeroth bright band. Then we have dark. This is first dark. This is first bright. Then second dark. Then second bright. Then third dark. So after a bright, you will have a dark. They'll come consecutively. Then bright, dark, bright, dark, bright, dark. I can draw like this. This is first dark, first bright, second dark, second bright, third dark, and third bright. It goes on like this. So on either side, you will see bands, bright and dark bands. Okay, actually, the dark bands have their energy lost, right? There was light there, but energy has gone now. But can energy be created or destroyed? Law of conservation of energy forbids it, right? Law of conservation of energy says that energy can neither be created nor be destroyed. All right. Energy can neither be. So the dark band energy has gone where? It hasn't gone anywhere. It has been added to bright band energy. So bright band has become brighter now. We will prove mathematically. We'll prove that mathematically. That's an important question. Is there violation of law of conservation of energy? No, never, never, never. Right. See, on a first look, you may think that energy is being destroyed here. You see dark bands, right? Darkness means energy is totally annihilated. But can energy be destroyed? No. Law of conservation of energy says that energy can never be destroyed. So where has energy gone? The light energy from that segment has been added to the bright band. So bright band has become brighter now. We can prove that mathematically later. And someone is asking a question, why is the central band a bright band always? I'll tell you the reason for it. That's again a previous board question. Central band is always a bright band, 0th band. That's also called principal maximum. Central band is always a bright band, 0th band. There is a reason for it. I'll explain that later. Anyway, this is what the experiment says. Is that clearly understood now? So I'll explain what happens now. This is a side view of Young's double slit experiment setup. Side view, a side view. Okay. So I have one slit here. I have second slit here. Side view. Okay. And there is a wave going over here. There is a wave going over here. Okay. And these waves are joined together at this point. At this point. Just imagine that the wavelength you use is 100 angstrom. 100 angstrom. All right. What was the condition for maximum you wrote? Delta is equal to n lambda, right? Delta is equal to n lambda was the condition you wrote. Let us check it out. All right. So this is path of the first wave. This is path of the second wave. I need to check if this is a maximum bright band or not. How do I find? I draw a perpendicular. I measure this distance. I get it as 400 angstrom. Just imagine 400 angstrom. So what is the path difference you got? Path difference is 400, right? It looks like 4 into 100, right? 4 is like n and 100 is lambda wavelength, right? So it satisfies the condition for maximum. So this is a bright band. This point is a bright band. Which bright band? N is equal to 4. N is equal to 4 means it's fourth bright band. Understood? If not, I'll tell you. Look at this. I'm taking another point. I'm coming over here. And I'm just drawing two waves. This is wave number 1. This is wave number 2. All right. Those are the paths. How do I find the path difference? I must draw the perpendicular. This is the perpendicular. And I must find the distance between them. I get it as 500 angstrom. 500. This 500 is going to be written as what? Delta 500 can be written as what? It is 5 into 100, right? 100 is my lambda. So I could say this is 5 into lambda. So n is what? That is actually fifth bright band on fifth bright band below the central band. The other one was fourth bright band above the central band. Understood? If you still didn't understand, I'll tell you. I'm going to take another point over here. I'm going to draw one path here, second path here. I draw the perpendicular. I get this as 700 angstrom. Can you tell me which band this is? Oh, tell me what's delta equal to 700 can be written as 7 into 100. So that must be which band? It is 7th bright band. Understood? 7th bright band. So this is how we get the condition for maximum or minimum. Similar way, I'm going to tell you the condition for minimum. Minimum, for the moment, I'm just writing down 2n minus 1 into lambda by 2. In school, they might take 2n plus 1, but never ever take it. Even though it's correct, never take 2n plus 1 because in numericals, you will definitely get wrong answers. So instead, take 2n minus 1 to lambda by 2. I'll try to tell you why. Okay, so this is the condition for minimum. I'll do that condition later. Anyway, let us check. Let us check another point. Okay, I'm wiping it. Otherwise, the figure will look too cluttered. Okay, right. So I'm going to check another point. So this is my source of light. I have two slits over here, and this is the screen. All right. I draw one wave. I draw second wave, and this is lambda equal to 100. I draw the perpendicular. I get this as 350. 350. So 3 into 100, no. 4 into 100, no. So it is not a bright band. Doesn't look like n lambda. So let us check the other guy out. I'm going to put that condition there. What is the minimum condition? 2n minus 1 into lambda by 2. So since maximum condition for maximum fails there, I'm trying minimum's condition. What is minimum's condition? Delta equal to 2n minus 1 lambda by 2. Delta is what? 350. C equal to 2n minus 1 into lambda by 2. Lambda is 100 by 2. 100 by 2 is 50. 50 and 357. 7 is 2n minus 1. 1 comes this way. 2n is equal to 8, which implies n is equal to 4. So this point must be what? That must be fourth dark band. Fourth dark band. Understood? So you have to check whether it satisfies delta equal to n lambda or delta is equal to 2n minus 1 lambda by 2. The condition for minimum or maximum. So that is a condition for maximum. If the path difference is found to be n lambda, that point will be a maximum or a bright band or a bright fringe. If that point satisfies the condition for minimum delta equal to 2n minus 1 lambda by 2, that will be a dark band. Understood this? So we have done the condition for maximum. What do we get for condition for maximum? I'll come back to this after discussing the condition for minimum. The condition for maximum, we got it as delta equal to n lambda. So you're going to find the condition for minimum. What is the condition for minimum? You remember this equation? I is equal to IA plus IB plus 2 root IA IB cos phi. For this to be maximum, I told you that cos phi has to be 1. And if this is to be minimum, what is cos phi? Cos phi has to be minus 1. The minimum value for cos phi is minus 1. Cos what is minus 1? Cos pi is minus 1. Cos 3 pi is minus 1. Cos 5 pi is minus 1. Cos 7 pi is minus 1. Look at that. They are all odd multiples of pi. So I can generalize it as 2n minus 1 into pi. You put n value 1, 2, 3, etc. In school, they might put 2n plus 1. But this is much better, okay? 2n plus 1 is also okay. If you're putting 2n plus 1, you have to start with 0. Okay, then the problem is there is no 0th band in darkness. 0th band corresponds to brightness only, the middle band, central band, okay? So that will interfere with your counting. Otherwise, you need to have what do you call thorough comprehension of that. So it's better to go this way. 2n minus 1 is easy because you can put n is equal to 1. You put n is equal to 1, 2 into 1, 2, 2 minus 1, 1 pi. N is equal to 2, 2 into 2, 4, 4 minus 1, 3 pi. Likewise, 2 into 3, 6, 6 minus 1, 5 pi. So this is in terms of phase difference. And I had told you to convert this to path difference. Path difference lambda is what? Path difference delta is what? Do you remember? How is the conversion done? Lambda by 2 pi into 5. If you remember, lambda by 2 pi into 5. So lambda by 2 pi into pi is what? 2n minus 1 into pi. Pi and pi are cut. You get 2n minus 1 into lambda by 2. This is the condition for minimum. So minimum's condition is what? Delta equal to 2n minus 1 into lambda by 2. But difference is what? Here you start n with 0. Here you start n with 1. And I have just reasoned it because n is equal to 0. 0th band is there only for maximum. Maximum means brightness. So let's see this one more time. This is our base equation. The resultant intensity is given by this equation. I is equal to IA plus IB plus 2 root IA IB cos phi. IA plus IB plus 2 root IA IB cos phi. That is the equation for resultant intensity. And what is the condition for maximum? How do you get the condition for maximum? I had told you to put cos phi as 1 there. For maximum, cos phi is 1. Minimum cos phi is minus 1. Minimum value of cos phi is 1. Minimum value of cos phi is minus 1. So I must put cos phi as minus 1. So which value of phi satisfies this equation? Cos pi, cos 180 is minus 1. Cos 3 pi, cos 5 pi, cos 7 pi. Previous case, they were all even multiples. These are all odd multiples. Pi, 3 pi, 5 pi, 7 pi, etc., etc. And if you can generalize this, you get 2n minus 1 into pi. Remember, never take 2n plus 1 like your teacher takes. 2n minus 1 is better. Or if you insist on that, you take 2n plus 1, but you have to start with 0. But that will interfere with your counting. Okay. For 7th band, you have to write n is equal to 6. That is a problem. But if you see n is equal to 3, that is 3rd band. You take it this way. Forget about all those things. You just take the phi as 2n minus 1 into pi, no matter what your teacher takes. 2n minus 1 into pi, where n is equal to 1, 2, 3, etc. 1, you put 1, 2 into 1, 2, 2 minus 1, 1 pi. You put n is equal to 2, 2 into 2, 4, 4 minus 1, 3 pi. N is equal to 3, 2 into 3, 6, 6 minus 1, 5 pi. So it goes on like that. Okay, yes, pi, 3 pi, 5 pi, etc., etc. And in terms of path difference, I need to get the condition delta equal to lambda by 2 pi into 5. This is the condition I wrote before, right? So lambda by 2 pi into What is phi? Written here 2n minus 1 to pi. So pi and pi are cut. It is 2n minus 1 to lambda by 2. So I got the conditions here. Condition for maximum is what? Path difference is equal to n lambda, where n is equal to what? 0, 1, 2, 3, etc. Condition for minimum is what? Minimum means dark band. Maximum means bright band. Minimum is delta equal to n minus 1 to lambda by 2. And the number should start at 1, 1, 2, 3, etc. And I told you how to take this. You know, this is an example question. We have this point. I need to know this point is what? I need to know this point is what? Can you hear me properly? So let us check with one example. I have 2 points here. One is P. Second is somewhere over here, that is Q. I need to check what all points are there. So first one, I draw one line, I draw second line. So somewhere here, I got the wavelength as 100 angstrom. 100 angstrom. Wavelength is given 100 angstrom. And when I draw first wave, second wave, and then when I draw the perpendicular, I get this path difference as say 900 angstrom. So 900 means what? I have to check with first equation. 900 is equal to what? 9 into 100. Perfect, perfect. 9 to 100. 900 is 9 to 100, right? 9 to 100. 100 is my lambda. So this is lambda. This is n. So it is what? N is equal to 9. N is equal to, so it's 9th band. 9th band. It satisfies brightness condition, right? So this must be what? 9th bright band. 9th bright band. So let us check the bottom one. This one. I draw one line, I draw second line, and when I draw the perpendicular, I get like say 650. I get 650. 650, will it satisfy this n lambda? 6 into 100 is 600. 7 into 100 is 700. So does it satisfy the first condition? No, 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 no. So I must check the second one out. So delta is 650 only, right? So 650 is equal to delta is 650. 2n minus 1 into lambda by 2. I'm trying the second equation now. 100 by 2. 100 by 2 is 50. 50 and 650 cut 13. 1 goes this way. Minus 1 comes to this side. So 13 plus 1, 14 is equal to 2n, or n is equal to 7. So this must be 7th dark band. So that satisfies the second equation, which is the condition for dark band. Apart from that, the number here is 7, which means it is 7th dark band. Is that clear now? So we have seen the conditions. I'll just write down the equations we learned so far. First one was principle of superposition of waves. Y1 plus Y2. Y vector is equal to Y1 plus Y2, which gave us an equation for amplitude as root over A square plus B square plus 2AB cos phi. That was the first equation we had. And then the second equation was the resultant intensity, which was written as IA plus IB plus 2 root IA IB into cos phi. The last term is called interference factor. And then we had the conditions for maximum and minimum. Delta is equal to n lambda. Path difference is equal to n lambda. 1 lambda, 2 lambda, 3 lambda, 4 lambda, etc. is the condition for maximum, whereas delta equal to 2n minus 1 into lambda by 2 is the condition for minimum. So this is the condition for maximum or bright band, brightness, whereas this is the condition for dark band or darkness. And n value, I told you, you have to start from 0 here, 0, 1, 2, 3, etc. Here n value has to be started from 1. I even told you the reason for this, even though it is not a matter of concern for you, you have to start with n equal to 0 here, and here you have to start from n is equal to 1. Because dark band, there is no 0th band. 0th band is always bright. Central band is always bright. Okay, 0th band is always bright. So I'll tell you the reason for that. That's a previous question. But before that, I'll tell you one more thing. Look at this. So I'm going to write down the condition for maximum intensity. not the condition, the maximum intensity equation. What is maximum intensity? IA plus IB plus 2 root IA IB into cos phi. Cos phi is what? For maximum it is 1. So I max is what now? This looks like what? This looks like A square plus B square plus 2 into A into B. If the first term is root IA, second term is root IB. So root IA plus root IB. Look at that. Root IA plus root IB the whole square. That is how I write I max. Look at that again. I max is given by what? IA plus IB plus 2 root IA IB into cos phi is 1 for maximum. And if I put that, and if I further simplify this, I'm going to get what? Root of IA plus root of IB the whole square. Similar way, if I put the value for minimum, I'll get I minimum as what? This is minus 1 for minimum, right? Minus 1. So this is minus. So that's going to be what? Root of IA minus root of IB the whole square. So what I needed to learn is one thing, the ratio of these two. This is very important for numericals. Even if they skip this in school, you have to learn this. I max by I min. It's very important for competitive examinations as well. I max by I min is what? Root of IA plus root of IB the whole square. You need to learn the equation only. They'll ask in numericals. Divided by root of IA minus root of IB the whole square. But there are other versions of this equation. Tell me, what is root of IA? You remember IA as KA square and IB as KB square. So what is root of IA? Root of IA will be root K into A. So root of IB will be what? Root K into B. So I can put here root K into A plus root K into B by root K into A minus root K into B, the whole square. So root K being common, they get cancelled out. And eventually you're getting what? A plus B the whole square by A minus B the whole square. I'll do one last thing. I'm going to divide everyone with B. A is divided with B, A by B plus B is divided with V, V by V, 1 whole square divided by. This is A by B minus B by B is 1 the whole square. This A by B is called amplitude ratio. A is amplitude of the first wave, B is amplitude of second wave. So this is ratio of amplitudes, which I can call R. So it is R plus 1 the whole square by R minus 1 the whole square. So that is our first set of equations. We got one more coming up. That's it. We'll have a numerical from this side. It's very important. Okay. I repeat one more time. This is our base equation. IA is equal to I max. Sorry. Our general equation is what? Resultant intensity is given by IA plus IB plus 2 root IA IB into cos phi. 2 root IA IB into cos phi. So that is the equation for intensity, resultant intensity in the case of interference. Okay. Whenever two waves join together or whenever two waves superimpose on each other, this is the intensity you're getting. I is equal to IA plus IB plus 2 root IA IB cos phi. So I write I max value here. What is maximum intensity? This cos phi will have to be 1. So IA plus IB plus 2 root IA IB. And this looks like A square plus B square plus 2AB, which is A plus B the whole square. So I'm rewriting this as what? The whole thing as what? This root of IA plus root of IB the whole square. Similar way, if I want I min, I minimum. First one was I max, I maximum. This is I minimum. This is I minimum. For minimum, cos phi value will be minus 1. So that will be minus 2 root IA. So that makes it minus root IB the whole square. Root IA minus root IB the whole square. So I need to find the ratio of these two. This is what is asked in numericals. I max to I min ratio is what? Root of IA plus root of IB the whole square by root of IA minus root of IB the whole square. But root of IA is what? We have taken IA as KA square and IB as KB square. So root of IA will be what? Root K into E. Root of IB is what? Root K into B. So I put them over here, root K into A, root K into B, root K into A, root K into B. All root K's are getting cut, leaving you with A plus B the whole square by A minus B the whole square. That is exactly what we want. A plus B the whole square by A minus B the whole square. Then I divide everyone with B. A by B, A by B, plus B by B. B by B is 1, the whole square, by A by B, A by B, minus B by B. That's again 1, the whole square. And A by B, A is amplitude of the first wave, B is amplitude of the second wave. So this is basically the amplitude ratio. So amplitude ratio is R plus 1 the whole square by amplitude ratio is R minus 1 the whole square. So R plus 1 the whole square by R minus 1 the whole square will be the equation for the ratio of A max to I min. Understood this? We have one more equation there in the reader. All right. You know, just imagine this is the source of light. I have two source slits here. This is the screen. Young's double slit experiment. Okay. One wave is coming from here, its intensity is IA. Second wave is coming from here, its intensity is IB. Now let me ask you, you tell me, if I open this little more, what will happen? If I open it up a little more light will come out, right? I could say that intensity is directly proportional to width of the slit, right? Oh, tell me what? You know, this is how the slit would look like. One slit and second slit. All right. And if I cut it open a little more like this, one slit is wider. Usually both the slits are of same size. Okay, just imagine both the slits are different, having different widths. You know, when the slit width is more, when I open it more light will come out. So width is intensity proportional to intensity. Intensity is proportional to width. So I can say intensity is equal to a constant into width. So intensity of A divided by intensity of B will be what? Width of A by width of B. But intensity of A is what? This is Ka square. Intensity of B is Kb square. It's equal to Wa by Wb. Finished. K and K are cut. What I need is the ratio of widths. Wa by Wb. Under root is what? A by B. You don't have to know this. You just learn the final equation. But I wrote the entire derivation because just in case you forget, you can formulate yourself. All right. So I'll repeat one more time. This is common sense, right? I have two slits here on the screen. Look at this. This is slit number 1. This is slit number 2. Slits are usually made using a blade. But I open, this is slit number A, slit number B. I open this slit a little more like this. So when the slit is wider, more light will come out of it. So how can I say this mathematically? When the slit width is more, intensity is more. Slit width is more, intensity is more. So intensity is directly proportional to width. How do you remove proportionality? By putting a constant. Intensity is equal to constant into width. So I write it for two cases. How? Intensity of first wave is equal to C into WA. Intensity of second wave is equal to C into WB. Then divide. C and C are cut. IA by IB is equal to WA by WB. So intensity of A is what? Ka square. Intensity of B is what? Kb square. Cut them out. You're getting what? A square by B square is WA by WB. Or if you take the square root of this, you're getting A by B. So this equation alone is to be learned by heart. That's very, very important as well. Width of the slits and amplitude are related by amplitudes are related by this equation. Amplitude ratio is square root of width ratio. Okay, so this equation is also important. Is that clearly understood, everyone? We'll do the questions now. So let's take the paper now. Question number A1. These are repeated questions. Two coherent monochromatic light beams. Coherent. I'll tell you about coherence later. Don't worry much about it. Two coherent monochromatic. You know what monochromatic is? Mono means single. Chromo means color. Light beams of intensities I and 4I are superposed. So I and 4I. I got IA, that is I. I got IB, that is 4I. Usually they are same, both are equal, but unless mentioned otherwise. But here they have specifically mentioned that first intensity is I, second intensity is 4I. Usually both the slits are identical, so both intensities are the same, I and I. Understood? If not given in the question, you can take both IA and IB as I itself. Both will be same intensity. Why? Because the slits are usually identical in size. If they are identical, the intensities will be same. Correct? Correct? If the slits are identical, the intensities will be same. Okay, so but here they have specifically given that they are different intensities. What is the question? Maximum and minimum. Direct question. Let us find maximum. What is the equation for maximum? We have this equation, so that makes it easy for us. Root of IA plus IB the whole square. Root IA plus root IB the whole square. Root of IA, that is root I, plus root of IB, that is root of 4I, the whole square. So this is root I plus root 4 is 2. 2 root I the whole square. So 1 root I plus, this is 1 root I plus 2 root I, 3 root I the whole square. 3 square is 9, root I square is I. Similar way, I can find out I minimum. I minimum is what? We have written the equation for this as well. IA minus IB the whole square. Root of IA minus root of IB the whole square. So that will be like what? Root I minus IA is I. Root 4I the whole square. So root I minus root 4I is what? Root 4 is 2. 2 root I the whole square. 1 root I minus 2 root I is minus root I the whole square. Minus square is plus, root I square is I. So the maximum intensity is 9I, minimum intensity is I. Answer is option C, 9I and I. Did you understand? All right. Okay, so let's look at the next question. Question number 2. If the amplitude ratio of two sources producing interferences 3/5. Amplitude ratio is given. So amplitude ratio is given means A by B is given. Amplitude ratio 3/5, right? Ratio of intensities at maxima and minima. I max to I min. Repeated question, I max to I min. It's easy. A by B plus 1 the whole square by A by B minus 1 the whole square. Okay, sometimes they'll give you the other way. They'll give you this value, they'll ask you to find out A by B, amplitude ratio. So question number 2. If amplitude ratio of two sources producing interferences 3:5, amplitude ratio is given. Amplitude ratio means A by B. Amplitude of the first wave A, amplitude of the second wave B. Amplitude ratio is 3/5. Ratio of maxima and minima. I max to I min is A by B. So 3/5 plus 1 the whole square by 3/5 minus 1 the whole square. So it may be asked in subjective examination also. Okay. Objective numerical 5 plus 3, 8. 8/5 the whole square by 5 comes here, 3 minus 5 minus 2/5 the whole square. What do we get? 64. 8 square 64. 5 square 25 by minus 2 square 4. 5 square 25. This and this are cut. 64/4. That is 16:1. Answer is option 16:1, option C. Understood this? Question number 3. In Young's double slit experiment, if the widths of the slits are in the ratio 4:9, widths of the slits WA by WB is given 4:9. Read it again. Question number 3. In Young's double slit experiment, if the widths of the slits are in the ratio 4:9, width ratio WA by WB is 4/9. The ratio of intensity at maxima to minima. So if WA by WB is given, what do you know? WA by WB is what? This is A square by B square. Correct. WA by WB is given as 4/9. 4/9. Correct. So WA by WB is what? Do you remember this? Check your note. We wrote it as A square by B square is 4/9, which means A by B, take square root. Square root of A square by B square is what? 2/3. And the question is ratio of maximum to minimum. What is the equation for I max to I min? I max to I min ratio is what? A by B plus 1 the whole square by A by B minus 1 the whole square. What is this? A by B. A by B is 2/3 plus 1 the whole square by 2/3 minus 1 the whole square. Previous board question also. So let 3 come over here. 3 plus 2, 5. 5/3 square, 25/9 by 3 comes here. 2 minus 3 minus 1 by 1/9. So 9 and 9 are cut. Answer is 25:1. And the correct answer is option C. Understood this? I repeat. See, question number 3. In Young's double slit experiment, if the widths of the slits are in the ratio 4:9. So width ratio is given, WA by WB is 4/9. WA by WB is 4/9, but WA by WB is amplitude squares ratio. A square by B square is 4/9. Why should I think of this? Because what I need is I max by I min, for which I will need A by B. So I need to get somehow, I need to get A by B. So A square by B square is 4/9. Take the square root, it is A by B. Square root of 4 is 2, square root of 9 is 3, so 2/3. And then I max to I min ratio is A by B plus 1 the whole square by A by B minus 1 the whole square. 2/3 plus 1 the whole square by 2/3 minus 1 the whole square. 3 comes here, 3 plus 2, 5. 5/3 square. 5 square is 25, 3 square is 9. Then 3 comes here, 2 minus 3 minus 1/3 square, so 1/9. 9 and 9 are cut, that makes it 25:1. Hope you understood that. Okay, let's move to the next one now. Question number A4. We'll do one last question. Question number A4. Two beams of light having intensities I and 4I. So two beams of light having intensities I and 4I. So IA is I and IB is 4I. All right. What are they doing? They interfere to produce a fringe pattern on the screen. The phase difference between the beams is pi/2 at a point A. So there are 2 points, okay, you're going to think about. So phase difference at one point is, this is point A. Phase difference is pi/2. And for another point, it's pi. Phase difference at another point is, say, some other point. I'm taking it here. Okay, for B, it is pi. What is the question? Then the difference between resultant intensities at A and B. Read it again. Two beams of light having intensities I and 4I. So first intensity is I, second intensity 4I. They superimpose, they interfere to produce a pattern on the screen. Phase difference between the beams is pi/2. They say that the phase difference is pi/2, where upon meeting at A, and pi upon meeting at B, then difference between intensities at A and B. I need to find the intensities at A and B. What is the equation for finding intensity? IA plus IB plus 2 root IA IB cos phi. That's what we wrote, right? So I am finding intensity at A first. I, capital A. Intensity at A. What is it? IA, that is capital I, plus IB, that is 4I, plus 2 into root of I into 4I into cos of pi/2. Why pi/2? Because they say that the phase difference upon reaching A is pi/2. Cos pi/2 is 0, cos 90. So I plus 4I will be 5I. I got IA. Next is IB. How do you find the intensity at B? Same thing. It is IA plus IB is 4I plus 2 root I into 4I into cos of, what is phase difference? Pi. Let us put it I plus 4I, that is 5I plus 2 into root of 4I square. Root of 4, it is 2. I square I. Cos pi is minus 1. So 5I. 2 into 2, 4I. 4I into minus 1. Minus 4I. So answer is I. This is equation number 2. The question is to find out the difference in intensities at A and difference. So here the intensity is 5I. Here the intensity is I. So the difference is 4I. Difference is 4I, and the answer is option B. Last question, I'll come back and do it in the next session. Okay. I repeat this one more time. What is the question? We have two waves joining together at A and then joining together at B. While superimposing at A, the phase difference is pi/2. And upon joining at B, the phase difference is pi. So I can find the intensities independently. What is the equation for intensity? IA plus IB plus 2 root IA IB cos pi. IA is given as I. IB is given as 4I. So I just substitute for them those values. IA, that is I, plus IB, that is 4I, plus 2 into root of IA, that is I, IB is 4I, into cos of phase difference for the first case is pi/2. Cos pi by 2 is cos 90. That will be 0. The whole term will be 0. I plus 4i is 5i. I got the first part of that question. Second part is IB. Actually, it's a previous JE question. IB is what? I plus IA plus IB. That is I plus 4i plus 2 into root of I into 4i into cos of, what is the base difference for second case? It is pi. I put it here. Cos pi is what? If you don't know, you have to write in the margin. Cos pi is minus 1, cos 180. So I plus 4i 5i, 2 into, this is root of 4i square. Root 4 is 2. I square is I. 2 into 2i 4i, 4i into minus 1, minus 4i. 5i minus 4i is I. IB is equal to I. I got IA, I got IB. The question is to find the difference between intensities, difference in intensities at A and B. So IA minus IB is the question. IA is 5i, IB is I. So the difference is 5i minus I is equal to 4i. Okay, so that's all from me for the day. We have finished the first part. Next is Young's double slit experiment and the numericals. Last part is diffraction. With that, the chapter will be finished. Okay, shall we wind up for the day?